Hello everyone, hope you all are fine. Once again, welcome back to Shaurav's classes. We are here with another video for tomato problem solving session, objective part. And for those who are already acquainted with these videos, already know what the purpose is, and those who are new, so let me explain you that tomato refers to this book, Test of Mathematics at 10+2 level. So why this book? Why not other book? This is because this video or this series of videos is only meant for people who are aspiring for Indian Statistical Institute or Chennai Mathematical Institute. Those are the premier institutes for mathematics, statistics, physics, computer science and other subjects in India. So they take admission and entrance tests. So why this book? So the answer of the question lies here, that this book is published by Indian Statistical Institute themselves and is one of the very important books. So every I.S.I professor who dedicated their time in making this book expected everyone to be thorough with these problems before appearing in exams of Indian Statistical Institute and Chennai Mathematical Institute. So they post the problems in such a way such that these types of problems, so they want to just give students a initial expression that what type of problems they are going to face or what types of problems they are going to experience in the actual written test examination of Indian Statistical Institute. So this book is a must for all I.S.I aspirants, and I recommend you to buy this book as soon as possible. The availability of this book is very easy. You can get it in any bookstore, and of course nowadays in times of net shopping or internet e-commerce, Amazon, Flipkart have wide range of these books kept. So today we will solve from this book because our aim in the video is very well settled, and that is I.S.I examination. So here we are back with the first problem. It says cos pi by 1000 plus cos 2 pi by 1000 plus up to cos, I just mentioned 899, so it's 999 pi by 1000 is equal to what? So is it 0, is it 1, is it 1 by 100, or it's an arbitrary irrational number? So I give you some time to solve and approach this problem before I get into the actual merged solution. So please see to it in the board. So the stipulated time that was made for this problem is over, and I hope that everyone here has tried. So trying a problem is very important. Solving is also important in exams. But before solving, I recommend you to try a problem. This is because unless you try a problem, you won't be able to get the essence of mathematics. And if you don't get into the essence of mathematics, you won't be able to understand how understand mathematics or its solutions, however good a teacher is. So the best thing to develop your problem solving aptitude or problem solving ability is try to solve problems. So this problem attributes to a specific trick or a concept that I'll teach you now. So this is a very important trick that I'm going to teach you, and this is popularly known as the Gauss trick. The Gauss trick is very important trick to solve problems, and this trick was employed by Carl Friedrich Gauss. So you have all heard the name of the mathematician as well as physicist. Many times in physics, in electrostatics, you might have learned about Gauss's law. In mathematics, there are several things related to Gauss. So we will learn this special trick that was invented by Carl Friedrich Gauss. So before letting the trick, so let me tell you a story. So this is a very well-known story that once there was a little boy who was in elementary school, and all the students of that school, of that particular section, was making nuisance. So the teacher got very angry, and because he had some personal work to do, and so what he did was he gave the students to add a series S equals say 1 plus 2 plus 3 plus up to 100. So he gave his student to compute this series, and remember that they were in class 1 or 2 that time, means they were just very recent to addition, so they have just got the addition concept. So the teacher gave this and thought that since it's a very big sum, it would keep people or the students very easy. Now all people in general, all the students, had tried to do it like this way. So 1 plus 2 is 3 plus 3 is 6 plus 4 10 plus 5 15, and they just proceeded and just went on to it. A bright boy, on the other hand, what he did was he said that let S be this expression. So this is S and let S be this expression. So what if I write S in reverse form? This is because addition we know is commutative. Plus 98 plus up to 1. So addition we know is commutative. So if I write it in the reverse form, then that also comes to S. Okay. Now what if I add these two equations? So he named this as equation 1 and this as equation 2, and he added it. So what did he get? 2S equals 101 plus 101 plus 101 plus 101 plus up to the n term. So 101 up to 100 terms. And isn't this amazing? So we know that how repeated addition works. Repeated addition is just a case of multiplication, isn't it? So what is 2 times 3? That is, I add 3 2 times. So I add 2 3 times. So that is the interpretation of 2 by 2 times 3. So this sum, what it becomes is 100 times 100. So S is 50 into 101. Sorry. So that is 5050. So wasn't this very amazing? So Gauss used this trick in that class, and his professor, naturally the professor was very elated to find Gauss in that way, and just leave alone the story. So we are not focusing on the story. So this is the Gauss trick. So the Gauss trick usually says that if you have a series like this and you observe the same sum pattern, what you need to do is just write it in the reverse form and add it. So this trick is not only applicable for these types of, for this sum specifically, but also the sum that we are dealing with from I.S.I entrance. So employing this Gauss trick, what was our expression? So let's name our expression as S. So S equals, the expression was cos pi by 1000 plus cos 2 pi by 1000 plus up to cos 999 pi by 1000. Okay. Now what did the Gauss trick say? So the Gauss trick say that write this series again in the reverse form. So I write this again in the reverse form. And what was the next step of the Gauss trick is just to add. So 2s plus this. Now observe that if I apply the rule of periodicity, we get that cos pi by 1000, we can just get this by just simple rule of periodicity. So cos is periodic from 2 pi. So the golden rule here that is applicable is cos n pi by 1000, cos 1000 minus n pi by 1000 and a minus sign. So the minus sign is, so what does it say? So this is a very important relation, that cos n pi by 1000 equals to minus cos 1000 minus n pi by 1000, which means that if the sum of these two, so the sum of these two is 1000, then just see the sum of the attribute that is attached to pi by 1000. So the coefficient number of pi by 1000, if they add to 1000 in both the cases, then their sum of the cosines is 0. So this is the relation that we state. So we see that 1999 plus 1 is 1000, so this is 0. And again this is 0. And again we get zeros, and we get 0 finitely many times, which adds up to 0. Isn't it? So what does S become? So S becomes 0. And according to Tomato book, Test of Mathematics, the answer is option B. So here is the answer. So you see that how we employed the Gaussian trick to solve this kind of problems, and like there are many kinds of problems you will get in I.S.I past years, in CMI, and in fact in the Test of Mathematics book, and in many other competitive exams, that people are giving problems like this. So what you need to do for problems like this, what I just taught you, is the Gaussian trick. Now when can the Gauss trick be applied? You just see that the Gauss trick can only be applied if the sum is always constant. The sum of the terms, or the sum of these differences terms, is always constant. So that's only when the Gauss trick can be applied. So this trick is a very famous trick and ingenious trick, I must say. So I recommend you to use this trick in future problems, whenever you encounter problems like these. So we will get back to the next problem. So the next problem is related to complex number and its locus. So what I'll do is, the question says, so the question says that find the locus of the complex number z such that Re, which means the real part of the complex number. So every complex number, as you know, has both parts, real and imaginary. So this is the real part. So the real part of 1 by z is 1 by 4. So you need to find the locus. And again, I give you some time to solve and approach this problem. Okay, so the stipulated time that was meant for this problem is over, and now I'll attempt to solve this problem. So whenever we need to find the locus of a complex number that satisfies a particular thing, it is always just better. So in this case, the locus was not as trivial because it involves reciprocals of z's and everything. So it's always safe to assume z as z equals to x plus iy. So just assume this. So z equals to x plus iy, you can assume. Then real part of 1 by z. So the real part of 1 by z can be just given as real part of z bar by mod z square. So why could I write it? This is because of the very important identity mod z square equals z into z bar. So just remember, this is a very important identity in complex numbers. We will use it frequently. So which is nothing but which can be written as x by x square plus y square. Isn't it? So real part of x by 1 by z is x by x square plus y square. So what we do is, now we just equate this. So x by x square plus y square is 1 by 4, and what we can do is that I can just multiply x square, just cross multiplication helps. So what I do is that I just add 4 on both sides. So you will soon realize why I did add 4 on both sides. And this. So what is this? This is the form of x minus a whole square plus y minus b whole square equals to r square, and this is a well-known equation of a circle. And hence the locus is a circle. So this was a very, again, a clean sheet type question, as I have said. This is because this question does not require any special trick or any special tip, just simple and clever manipulations, and what the concept was required was this thing. So this is one of the most strongest and important identities, I can say, in the area of complex numbers. And without wasting further time, I just want to rush to the next problem. So the next problem is the locus of Z. So question. So the question says that the locus of Z, for which Z plus I by Z minus I is purely imaginary, is a straight line, a circle, an ellipse, or a hyperbola. So I just give you a few minutes time to try and attempt and solve this question. Okay, so the stipulated time that was meant for this question is over. So I hope that everyone have tried this question. So before me solving the question directly, so let me just enlighten you. So let me just enlighten you about the fact that in the previous problem I have said that in locus type questions it's better to take x plus iy as the form and just manipulate it. Now that is a general form that works for every problem. But remember that there are a lot of problems which do not require any computation, but they require just some simple geometric tricks and theorems which we have learned in our elementary classes. So this is one of those problems in which I will not substitute z equals to x plus iy, that is, I will not get into the conventional method, but I will solve this with a specific trick using some geometry, just some geometrical theorems that we have learned earlier. So let's explore the solution. Now what we do is that z plus I by z minus I. So what does this expression literally mean? So we know that this ratio always refers to some specific angle. How? Say this is a plane where the plane and here the z is located. So this is I and this we all know is minus I. So what is z minus I or z plus I? Z plus I is the distance of this point to z. So this is the distance. So distance is known as z plus I. So for that you need to know the geometry of complex numbers, that what is distance and all. So this z plus I is basically the distance of z and minus I. And z minus I is the distance from z to I. Okay? So these are the two distances that I have mentioned here. Now you see that this vector, so if I treat this as a vector and I treat this as a vector, then I want to find that what is the argument of the expression z minus z plus I by z minus I. So what I need to do is, what I am trying is that I want to find an expression that goes, so since this is written, so I just want to go clockwise like this. So I need to find that what this angle is. Okay. Now we will just use some simple geometry. Now since z is a locus and it's a moving point on the plane, so I just say that z is a moving point on the plane. So what if I place this z on x-axis? So what if I just translate and bring this z down to here? So how the figure will look like? Something like this. Isn't it? So the figure looks something like this. And you will observe that since this is just a shift, this angle is equal to this angle. And not only that, this is equal to pi by 2 or 90 degree. This is because I times 90 degree is pi by 2. That is, if I go 90 degree from 180 degree from here to here, then I'll get minus I. From I, if I set a vector and turn around 180 degree, I'll get minus I. But here minus I is not the exact requirement. I require minus I the half of the distance. So what is half of 180 degree? Half of 180 degree is 90 degree. So what we have got is, this is 90 degree. Now we all know that angle in a semicircle is always 90 degree. And therefore we can assume that this is a circle. So this is the circle. That goes, and therefore what is the locus of the z? In which point does z lies? So the locus of the z is a circle. So according to test of mathematics, the answer is option B. So let me explain the solution again to you. That what happened was I chose an arbitrary point z, and the distance between, and z minus I is basically the distance between z and I, and z plus I is basically the distance between z and minus I. So I just constructed the two distances and I just shifted z from here to here. This is because z is a freely moving point. I can just shift it to anywhere I want. So I shifted z and I got that it is basically 90 degree. And what did I use? I used the old geometry theorem that we used to learn in our junior classes of 9 and 10 or 6 or 7, that angle in a semicircle is always 90 degree. And therefore, since this is an angle in a semicircle, z must lie on a circle. Therefore, the answer is circle. So, by comments, I must say that this is a very good trick, and these sorts of trick must be utilized. So, for utilizing these sorts of tricks, you must have a strong base build up in geometry. So it's never too late to learn. So you can right now get back to the concepts of, or you can just go through the books of your junior classes in which you learn those theorems. So if you have thought in your junior classes the theorems that you learn are useless, they aren't actually. They are just accelerated way to solve these kinds of problems without using complex numbers. I never say that this cannot be solved by the conventional method, but I say recommend you rather to use these tricks. You see that if I had substitute z equals to x plus iy, the question would have been, that solution to the question would have been unnecessarily long. Okay. So let me get down to the last question of the day. So a sufficient condition Okay. So it says that a sufficient condition that the roots of x squared plus bx minus 4 equals to 0 are integers is this. The four options: b equals to 0, plus minus 3, b equals 0, plus minus 2, 0, plus minus 1, or none. And this is a quadratic equation, x squared plus bx minus 4. So again, as per the rule I follow, I want to give you some time to try and approach the problem. Okay, so the stipulated time meant for this question is over, and now I'll get back to the solution. So before getting into the solution, I want to give you an important concept. So the concept that is on which the question is based is that integer roots of quadratic equations okay. So integer roots of quadratic equations. So this is the concept that we will be dealing with today to solve this problem. So number one, so conditions. So the conditions for a quadratic equation to have integer roots is that number one, A, B, C must be rational numbers. So the first and the primary condition for having integer roots is A, B, C must be rational numbers, because you can easily see by yourself that if one of the coefficients is irrational, then automatically the roots cannot be integers, of course. This is because if the roots are integers, then it will imply a rational plus an irrational is equals to rational, but that is false. So first of all is very important condition that A, B, C must be integers, and number two is that suppose we have the quadratic equation x square plus, so ABC in the equation I mean ax square plus bx plus c. So I just transform this equation and b by a whole x plus c by a equals to 0. So I just name it as p by q. Okay. So what is the concept? The concept is that the roots of the equation here are, we know that by Sridharacharya's formula, minus p plus minus root over okay. So these are the roots of the equation. Now for the first and the foremost thing is that to be the roots to be an integer or rational, this cannot be irrational. So this must be rational. Now if this quantity there, the discriminant, that is rational, it automatically implies that discriminant must be a perfect square. So this is a very important condition. Discriminant must be a perfect square for existence of integer roots of quadratic equations, and this is the relation we will first exploit to find the roots of the quadratic equation of this problem. So we will use these two rules, and the equation given to us was x square plus bx plus 4. So by our first condition, x square and minus 4. So x square, 1 and minus 4 are already integers. So b must be an integer. So the first condition is b must be an integer, and the second is the discriminant must be a perfect square. So b square, what is the discriminant? B square plus 4 into 1 is a perfect square. Say p square for p belongs to z. So b square plus 16 equals p square, and 16 equals p square minus b square, which is can be factorized as p plus b into p minus. Now this is very simple. Since p is an integer, b is an integer, p is an integer, and b is an integer. So for their products to be integers into 16, so we must see that how many factors of 16 exist. So 16 can be written as 16 into 1, 4 into 4, 2 into 8. So these are the possible ways to write 16. So these are the only possible ways to write 16. And therefore, if you just substitute it with this equation each time and solve it, you will ultimately get b as, so I leave the solving part up to you, as 0, plus minus 3. So according to Tomato, the answer is option A. So this concept is a very important concept in theory of equations or in theory of quadratic equations in general, and I recommend you to just learn, remember and practice problems on this. Okay. So again, as I said, that in this video we have come across a lot of problems in a lot of solutions, and most importantly we have come across a lot of tricks. So I recommend you, so in every end, as I say, that mathematics without pen and paper, doing mathematics without pen and paper is simply useless. So you always need to keep a pen and paper in hand while doing this, and the knowledge or the practice does not restrict with this particular video. So your mathematics ends with this particular video is not at all true. So it must not be true. So you should practice these conceptual problems or try to utilize these tricks and concepts wherever you get a problem like this. And of course, I would say that today you have learned many important tricks, and without practicing those tricks, as said by an age-old proverb, practice makes a man perfect. So without practicing these tricks, you won't be perfect. Implementing these tricks would require you to solve much more problems beyond the tomato level, and I would recommend you to purchase or to get a copy of your study materials from Saurav's classes. They contain a rich volume and rich amount of problems that goes parallel to I.S.I, and also the tricks are explained lucidly in the study materials. And so I recommend you to just go through this and have a wonderful exam with a wonderful future. Thank you and stay tuned for the next one.